Greetings, Earthlings. Today we're going to take a look at the machine language assembler for the stupid computer. You've seen how we can enter programs through the front panel switches, but of course that gets a little tedious and error prone as we get into larger programs. So it's fine for something like a hello world or just an echo program. But if we want to do any substantial, significant programming, then we really need to be able to write it in assembly language, not in a high-level language. That's just me. And be able to assemble it. So the assembler I have written, as with the microcode assembler, I've written this in Perl just because that made it real easy and fast to do. See, it's not a very big program. Still have some things to do, but it's to the point where it's basically somewhat functional, and we can demonstrate its operation. So where's my cursor? Oh, there it is. What I'm going to do, whoops, I have, you can see here, I've written, well, we had LD test before. Well, I don't know if you saw those, test.asm, LD test. That's just stuff I've done. But the two we're going to be looking at today are Fibonacci.asm and primes.asm. Okay, this one generates Fibonacci numbers up to 64 digits in length, and primes will compute primes up to 1,000. And you can see, 3,600 bytes, 4,000 bytes. We're getting into some fairly substantial chunks of code. If we look at, if we look at the Fibonacci, why is that highlighted? I don't know. The Fibonacci program. This is what the assembly language looks like. It looks a lot like assembly language. So I wrote these just basically to test the operation, well, of the assembler and of the computer itself. And so you can see it's not horribly long, but it will do what we want it to do, hopefully. Okay, now I've called the assembler TASM. Why is that? I don't know. But we'll assemble Fibonacci program. Well, let's first do this. Let me do this. Dir fib star dot star. Okay, so all we have is the ASM file. Okay, good. So now Perl tasm.pl Fibonacci.asm, boom. 327 statements. You see, it's plenty fast. So even if I had several thousand statements, it would still be perfectly adequate speed-wise. So there's no reason not to write it in Perl, really. Because my biggest concern would be the how long it takes. You can see now that it's generated a binary file, and it's generated a listing file. So if we look at the listing file, you can see this is the address here. This is the incoming line number, or whatever, the source code line number. This column is the address, and this is the code that gets generated. So look at that. All right, zoom. Okay, and then the symbol table at the end there. Okay, so we'll start now by plugging in the stupid computer and watch the lights blink. Whoa, that's just always so cool. That's doing the power on memory test, or power on self test. Well, it's mostly testing memory, but it tests other things as well. Okay, so now I want to make sure that the serial port is connected by the serial port. That's the only I/O device on this computer. I want to make sure that the serial port is set to 9600. So that's in here somewhere. Oh, don't look at these. You can tell I've been I've been testing this. I'm looking for one that says mode. Oh, it's not there. Okay, mode. COM5 9608-1. Boom. Okay. So now I'm going to press the load switch here on the computer. And over here, I'm going to say copy. Which one are we doing? Fibonacci? Fib.bin to COM5. All right. Oh, and you're going to want to watch these lights. Watch it as it loads. Okay. It's now loaded. And so now we'll switch over here to hyperterminal. And hopefully that's connected. Let me just verify. Well, did it show connected down at the bottom? Yeah, 9600. Okay. So we're connected over here. And starts at 0. So I'm going to press start. Press any key to begin. Woo. Now what I've also done, you see that's going to scroll very quickly. Pressing any key pauses it so that we can take a look. Okay, Fibonacci sequence, for those who are not familiar with it, you start with 1, 1, 1, and then you add those two numbers together, and that's the next Fibonacci number. So 1 plus 1 is 2, and then you add the previous number to that. 2 plus 1 is 3, 3 plus 2 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on. They get large very fast. And this is going to go up to 64 digits worth, okay? And I'll leave it to you to verify that these are actually correct values. We could sort of look. 5 and 8 is 13. 8 and 4 is 12. Carry the 1, that makes 14. 8, 9, 10. So you can see it's at least plausible that it got those right. Okay. So there's your Fibonacci numbers. I'm going to go ahead and disconnect, and let's play with primes. Okay, so Perl tasm.pl primes.asm. Okay. Primes dot star. Okay. 450 bytes for the binary. Well, what did it say when it assembled? 146 statements. That's probably memory locations. That probably includes data statements. I don't remember exactly how that's computed, but I think that's actual instructions plus data. Okay. And 146, the other one was over 200. That's a little more than you want to toggle in on the front panel, you know. And I'll keep writing additional programs that get even bigger. But that's to come later. Okay, more primes.list. It's kind of crufty the way the code is written, but and I'll probably change it because okay. So over here, let's load it up and I'll show you everything. Okay, I'm going to press load, and here I'm going to say copy primes.bin to come 5 colon. Now watch the lights, watch the lights. Okay. And go back here. Oops, go back here, and we're disconnected right now. So I hit enter, now we're connected again. And this also starts at 0, so I'll press start. And it says prime numbers, press any key to begin. Well, I kept that, I cut and pasted that same code. And this one also has the pause, press any key to pause. So I'm going to press the space key twice quickly. Uh-oh. It didn't work, and it broke. Okay, what happened? I don't know. This worked before, I swear. Let's try loading it again. Let's try loading it again. Disconnect. Load. Yeah, go. Okay. Start. Press any key to begin. Oh, there it goes. Okay. Yeah. And I wasn't very fast on the, I was not very fast on the pause. Okay. So that went zooming by. Well, it's all still there. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Those look like prime numbers to me. And 997 should be the last one it showed. Oh, look at that, 997. Okay. So that is assembling programs and loading them into memory. Obviously, more to come in the future.